What I intend on doing is going through this practice and doing the odd problems as a class. We'll talk about some things that you'll expect to see, further on in the assessment, things like that. And then the evens, all the even problems will be due for homework tonight. Okay. So odds we'll take care of as a class, evens will be due for homework. So it's imperative that you make sure you access this practice here. All right. This is going to be a variety of problems that we've seen over the course of section 6.6. So some where we're just kind of rewriting and simplifying, some where we're using those exponent rules like we used yesterday. So just kind of be aware of the different problems you might see. First question here, we'll go to number 1. So I have 81 to the 1/2 power. If something's raised to the 1/2 power, that's the same thing as doing what to that number or what to that variable. If it's raised to the 1/2 power. So that's if it's raised to the first power. You take the square root, right? This is technically 81 to the first power, and then with that index of 2. Well, if the index is 2, that means I'm taking the square root. What's the square root of 81? 9. So a way to simplify this is to just take it from this exponential form, write it in radical form, and then solve. Right? And you're going to see that a lot when you have constants raised to exponents like that. Like you'll do it on your own with example 2, and a little bit more throughout the homework as well. Okay. Any questions about number 1? We'll jump over to example 3. Like I said, we're going to go through the odds. I have the same base and I'm multiplying them together, right? So I have some base raised to an exponent, multiplied same base raised to actually the same exponent here. What am I doing with my exponents if I'm multiplying? You add them. So this is really 10 to the 1/2 plus 1/2. Half plus a half gives me a whole or 1, right? So this is 10 to the first power, and anything raised to the first power is just what? Itself, right? So my answer here is 10. Okay. Starting to see some of our rules from yesterday in our practice for today. Quick side note, for tonight's homework, you can skip over number 4. So you're doing all the evens except for 4. So if you want to cross that out, you can go ahead and do that just so you're on the same page. Let's go down to number 5. Very similar type of question. How would I start by solving this? So I have 64 to the 2/3 times 64 to the 2/3. What should I do in order to kind of combine those, break it down a little bit, simplify? Who's got an idea? Nick? Add the exponents, right? So I have 64 to the 2/3 plus 2/3. That's going to give me what, though? What's 2/3 plus 2/3? 4/3. Well, just like we saw in example 1, I have a number raised to this fractional exponent. It's a good time for me to put my answer in radical form. So this is really 64, taking the cubed root of that and then raising it to the 4th power. Well, something that we touched on in class, not for a very long time, but we did talk about it last week at some point, was that this is the same thing as taking the cubed root of 64 and then taking the 4th power of that whole expression. Okay, so whether I do the 4th or raising it to the 4th power inside my root or outside, it's going to give me the same answer. Does anybody know what the cubed root of 64 is? You can think as you're kind of copying things down here. 4, right? What number multiplied by itself 3 times is going to give me 64? It's 4. 4 times 4 is 16, times an additional 4 is 64. So this is 4. If I simplify what's inside my parentheses there, And then I'm raising that to the fourth power. Well, what's 4 to the fourth power? And you can use a calculator if you need to, or some kind of, what's that? 256, good. Any questions about anything from this first page so far? So numbers 1, 3, or 5. Everybody good? Okay. Jump over to number 7 on the next page. Continue with our odds. I have x to the fourth times y, and that entire quantity is being raised to the 1/2 power. Well, think back to what we did in number 1. If I'm raising something to the 1/2 power, it's the same thing as doing what? Taking the square root. Good. So I have x to the fourth y, and I'm just going to combine these. Don't get thrown off with that extra punctuation. That just means you're multiplying them, right? This is the same thing. And I'm taking the square root. And the reason that I want to show this is because if I'm simplifying this and breaking this down, there's no operation that's taking place, right? Everything's, it's one term that I'm taking the square root of. I need to think back to what I did early on in section 6.6, which is just to kind of rewrite this and simplify with my powers and indexes, right? Take this one variable at a time. I have x to the fourth. I'm taking the square root of that. So what should go in my numerator? What should go in my denominator of my exponent? What's that? 4/2, right? The index is 2. Even though it's not written there, we assume that because it's the square root, it's the 2, right? What's the power for y here? What's y being raised to? Just the first power. So I have y to the 1/, index is still the same, which is 2. Are there any questions up until this point? Okay. Well, 4/2, that simplifies to what? Just 2, right? So this becomes x squared, and then y to the 1/2. Well, remember how we started, right? We took something that was raised to the 1/2 and put it under a square root. We can do the same thing with an individual variable. So we can think of this as x squared times the square root of y, and that's how I would want to leave my answer. Again, whenever we have a fraction as an exponent, we want to think to write our answer in radical form. Okay. Any questions about that example? Okay. Keep moving along here to number 9. I have x to the 4/7, and that entire quantity is raised to the -7. Now, this isn't something that we talked about yesterday, but we did talk about it in chapter 5. When I'm raising a power to a power, what operation is taking place between those exponents? Because right now we have, if we multiply same base, we add exponents. If we divide, we're subtracting. What happens, do you think, when I raise a power to a power? What operation is going on there? Multiplication, good, right? So I'm multiplying the 4/7 times the -7. Now, to be completely transparent, this might not be something that you see on like a test or quiz or anything like that, but it's good for us to take a look at this for a couple of reasons. First, to review that idea where I multiply a power by another power if I'm raising them. And how does this simplify? What happens to this 7 here and this 7 here? They cancel. I'm left with x to the negative 4th. So it's good to review, not only to know that a power raised to a power we multiply, but also notice I'm left with a negative exponent. Well, there was a rule that we had with negative exponents. If I raise something to a negative number, it's the same thing as doing what? Does anybody remember what that exponent rule was? We're going to see this a little bit later on as well. So if I raise something to the negative exponent, it's the same thing as writing it in a different form with maybe a positive exponent. So anything raised to a negative exponent is the same thing as taking that number and putting it in, or taking this term here, putting it in the denominator with a positive exponent. So my final answer here is 1 over x to the 4th. Again, something that you might not see on a test or quiz, but it's a good refresher for us to understand our exponent rules and make sure we really know that everything that we do here can be applied to our radical expressions as well. Okay. Any questions about that example? I know it's a little bit more, I guess, diverse than some of the questions we've seen so far. Everybody good? Okay. Number 11. Now we're going to start to get kind of into the nitty-gritty of what we did yesterday. I have the cubed root of y to the 9th power divided by the 9th root of y to the 3rd power. Remember our steps when we see division or multiplication. We need to change our root expression to an exponential expression and then kind of simplify from there. Well, if I'm just looking at maybe my numerator, what would be the exponent of my numerator if I'm changing it from the cubed root of y to the 9th power? How would I write that as an exponential expression? Nick? 9 over 3, which just simplifies to what? 3, right? So I can just write it as y cubed. Remember that you take your exponent, what's on the inside, and you divide it by the index, right? That number on the outside. Well, if that's the case, what should be the exponent in the denominator? 3 over 9 or just 1/3, right? Does everybody see how we got each of those values there? When I'm dividing and I have the same base with these exponents here, what do I have to do with the exponents if I'm dividing? What operation? Subtraction, right? So this is really 3 minus 1/3 as an exponent of y. So y to the 3 minus 1/3. We should all notice that I have different denominators here, right? Technically, this is 3 over 1 minus 1 over 3. What would be my common denominator? Because I need a common denominator here to kind of simplify. Just 3, right? Anytime you have 1 in another number, your common denominator can just be that other number. So I ask myself, all right, well, what do I have to multiply 1 by to get to 3? 3, I have to do that in my numerator as well. So this is really 9/3 minus 1/3, which gives me what? 8/3. Good. This is the first time we're seeing that common denominator pop up. Does anybody have any questions about that idea? We saw it yesterday, but from today, hopefully we're all right with how we get to that point. Now, a siren should be going off in our heads. All right, I see that my answer right now has a fractional exponent, which means I have to rewrite it in what form? Radical form, right? Good. So if I'm rewriting it in radical form, which number is my index and which number should be on the inside as my exponent? Good. 3 is my index. 8 is my exponent. It's always the denominator is the index. That's going to go on the outside. Numerator is the power, which goes on the inside. Okay. Good stuff. Any questions about that one? Okay. 13. I have the 7th root of 7 times the cubed root of 7. All right. My first goal is to rewrite this in exponential form. So this is going to be 7 raised to what power for the first term? 1/7, good. Times 7 raised to what power in the second term? 1/3. Nice job. When I'm multiplying and they have the same base, I do what operation with the exponents? You add them. Good. So what Nick here in class said was, yes, I add my exponents, but he noticed that they had different denominators. So I have to find a common one, which would be 21. Well, for that first fraction, I'll give you a second to kind of jot this down as I'm talking. For the first fraction, what number I multiply 7 by to get to 21? 3. I have to do that in my numerator. So 3 times 1 gives me 3. Pretty much the same question, just flipped. I multiply 3 by 7. So I multiply 1 by 7 here. So what's my final exponent? What's 3 over 21 plus 7 over 21? So I have 7 raised to the 10 over 21 power. And again, we should notice that we have a fraction as an exponent, which means we have to rewrite this in radical form. What's my index? 21. What's my power? 10. Again, this is probably the second or third time I'm saying this. Numerator is your power. Denominator is your index. Question. Okay. Right. So numerator 10, index power. My apologies. Denominator 21, index, the number that goes on the outside. Right. Same thing every time. And we went over that at the beginning when we were just kind of rewriting in between each of those different forms, when we went from exponential to power to radical and vice versa. Are there any questions about number 13? Okay. Number 15. Very similar. This is x raised to what power in my numerator? My denominator, it's x raised to 5/6 or 5 over 6. When I am dividing, what do I do with my exponents? Subtraction. This is x to the 1/3 minus 5/6. Is everybody with me so far? Are there any questions? Okay. What's the common denominator? Because right now I have 3 and 6, right? What's the common denominator between 3 and 6? 6. So what's 1/3 going to convert to? 2/6 minus 5/6. Well, what do we notice about our exponent there? What's it going to become? Negative, right? Negative, what's the number? -3/6, which we know is also negative what? 1/2. I'll let everybody write that down before I make my point off of this. Everybody up to speed? Everybody good? So the reason that we take a look at something like number 9 from before, remember we had a negative exponent here, we write it as 1 over whatever that term was, right? It's the same thing. I have 1 over x to the positive 1/2 here. And we know that anything raised to the 1/2 power is the same thing as taking the square root. So this is really 1 over the square root of x for your final answer, because I still have that fraction. I want to write it in radical form. Now, a question came up in an earlier class. Well, I thought you said we don't want to have radicals underneath our square root. When you're simplifying, I'm fine with you leaving your answer. Technically, yes, you wouldn't want to leave a radical in your square root. You want to rationalize that, which we talked about in section 6.5, if you remember that from earlier on last week. But for your final answer here, I'm fine with you leaving it the way it is, okay? Any questions about 15? Okay. Last question for today, and then I'll outline what the homework is and some of the things about tomorrow as well. I've a little bit of a different problem here. What do we notice is different about 17 comparative to everything we've done so far? 2 variables, right? I have a, b underneath my square root, and we saw something like this yesterday, okay? The steps don't necessarily change, though. I'm still converting in between my radical form and my exponential form, right? The only thing I would say and suggest to do is take it term by term. So I'll start with that first term, and then I'm going to work variable to variable as well. Break it down for yourself. If I look at that first term, the cube root of AB, A is being raised to what power? First. Good. So this is 1 over whatever the index is. And what's the index for that first term? 3. So I have a to the 1/3. B is also being raised to the 1/3, right? Because that's a power of 1. Index is 3. Do we all see how we got each of those terms there? I'm multiplying that by, again, now I'm going to work with my second term. A to the 4th divided by 6. Well, what's 4 over 6 simplified to? 2/3. If you need to write the 4 over 6 and then simplify it in another step, that's fine. But what I would suggest doing as we kind of start moving along here, just to create less work for yourself, a to the 4 over 6 is the same thing as a to the 2/3, right? B, however, is raised to the 1/6 power still, because I couldn't simplify that fraction any further. Well, one thing that we talked about yesterday in class was I can only combine things that have the same bases, right? The bases need to be alike in order for me to use my exponent rules, right? So with that being said, I'm going to take this step by step here. And I'm just going to work with the a's. I'll have a to the 1/3 plus 2/3 because I'm multiplying, right? Right. And 1/3 plus 2/3 is just going to give me a. Does everybody see how we got that value, right? 1/3 plus 2/3 is just 1, or a to the first power. You don't have to write the 1 in, right? We just assume. B, I have 1/3 plus 1/6. What's that? I have to find a common denominator, right? Which is what? So it's 1/3 plus 1/6. Right. So you're converting. Okay. So the common denominator you're saying is 6. So I'm going to convert this to b to the 2/6 plus 1/6, which is what? The 3/6 or a half. Okay. Take a second to jot that down. I know I went through those steps quickly, but we noticed that there is not a common denominator here, or excuse me, that they don't have the same denominator. So we have to find a common one, which is 6. So we convert the 1/3 to 2/6, add those together. But then if I get 3/6, I can simplify that to a half. Does everybody follow along with those steps there? Well, anything raised to the half power, we can also write as the square root of that value. So my final answer here is actually a square root of b. Right? Remember, I'm multiplying those values together. Although I took it variable at a time, the operation in between is still multiplication. So I'm multiplying my values in the end. Are there any questions about that example or any questions about anything that we covered in class today? Everybody good?